Okay, good morning, everyone. Okay,
Morning.
yes, good morning. Yesterday, I have shared the documents with you. Did you receive that? In email, you can just download that zip folder where all the PPTs are available, whatever content we'll be taking in this live classes. Did you receive that?
Yeah, got it, man.
Okay, so you can download and you can start referring the same. And even I have asked you to prepare for two module, like just gone through the two module, like what are the fundamentals in software testing and the testing principle which we have covered yesterday, right? So based on that only today I will be starting with the ISTQB questions first of all, and then we will continue with our main topic, right? Software development life cycle. Okay, so let's start. What you need to do is just write your answer, whatever answer it is, in the chat box, and then we will have a conversation based on the same. Okay. So first question we have already discussed yesterday. Even I think two questions we have done yesterday, right? So when what is visible to end user from the specific or expected behavior or deviation from the specific expected behavior, this is called failure. Okay. Whenever there is a deviation for a software delivery, like what customer is expecting and what exactly we are delivering, if both are not same, definitely that difference is simple referred as a failure. Okay. And whenever it is visible to the end user or customer point of view, that's surely failure only. Because in the QA environment, whenever you identify any fault from the software application, then only you can say that is what a defect. The fault, defect, bug, every this keyword is same. Okay, its meaning is same only. The one more point is what, at a broader level we can call it as a defect, like somewhere anything is not matched with the expected result, that we can refer as a defect. But somewhere some technical issues are there, somewhere related to the code, related to the development. If you found any technical particular issue, that technical part you can simple refer it as a bug. So bug is at a small module level, we can say. But defect is a term that we can access, that we can use at a broader level. So yesterday we have seen three keywords like error, fault, failure, and what is the difference between three. Error is just any mistake which is done by the human, or any action which generate incorrect result. That is called error. Fault is what, manifestation of error into software application, that is called fault. And failure means anything which is not matching as per the customer need and which is visible to the customer, right? So deviation of a software from its expected delivery, that is we can refer it as a failure. Okay. Second question, testing should be stopped when? As I told you, in ISTQB you'll be getting multiple choice questions and most of the options are similar, and we feel that okay fine, every option is correct, but you need to write your appropriate answer, right? So generally all planned tests have been run, we can stop testing, that's true. Time has run out, then only we can stop testing, that is also true. Even all fault have been fixed correctly, this part is also true. But the relevant answer for when to stop testing, it's totally depend on the industry, correct? So we can simply define the risk of the organization and that particular software which you are testing. So appropriate answer for this question is, it depends on the risk for system being tested. Okay. Third question also we have discussed yesterday, right? Non-functional system testing includes what? So generally non-functional, it's all about quality attribute of a software application. So it could be anything, right? But here the option is written that testing quality attribute of a system including performance and usability. So rest of the options are not correct. Correct answer is here B, that quality attributes are nothing but non-functional system testing. Okay. Now let's start with next question. Here it is a question, pick the best definition of quality. Now you try. I think from this question, now we'll be checking that, okay, which option is correct. So what do you think? Pick the best definition of quality. We have discussed a lot of time what is quality, right? So options are quality is a job one, zero defect, conformance to requirement, or work as design. So think properly and write your answers in the chat box. Okay. Yeah, try everybody. Okay. Most of the answers. Okay, I can see. Yeah, fine. So correct answer is definitely C, conformance to requirements. Right. Okay, so quality means meeting the customer expectation as per the requirement, as per the need of the customer, right? Where we can simple focus on the customer requirements. Even we can focus on the duration, that particular budget and service offered to that customer. Okay. The next question, one key reason why developer have difficulty to testing their own work. So it's because of lack of technical documentation, lack of test tool in the market for the developers, lack of training, or lack of objectivity. So one key reason why developer have difficulty to testing their own work. Think properly. One key reason why developer have a difficulty to testing their own work. Is it lack of technical documents or lack of test tool available in the market or lack of training or lack of objectivity? Okay, so this is related to the first session. Okay, I have discussed with you that developer and tester both are having different roles, responsibilities, correct? And even objective is also different. Developer is responsible to develop the quality application, and tester is responsible to test the application, break the application, and get the defect, correct? So basically, when it comes to the one key reason why developer have a difficulty, it's not because of lack of technical document or there are no tool or test tool are limited right in market. No, no, no. That's not a correct answer. Even lack of training. That's not a correct answer. Correct option is option D. Lack of objectivity. Generally, developer is the only one person who is developing that application. So it is quite difficult to identify the problems in that application. Are you understanding? So it's a lack of objectivity. Okay, the correct answer is here is what? Lack of objectivity. Not about document, not about testing tool. I hope it is clear, right? So in this question, right answer is what? Lack of objectivity. Okay, try for next. During the software development process, at what point the test process can start? So when the code is complete, when the design is complete, when the software requirement have been approved, or when the first code module is ready for unit testing. So basically, it's a question related to entry criteria. When we are going to start testing, correct? So during software development process, at what point can the test process start? Yes. So I got the answer. Yes. Try everyone. So when we start testing that we have already seen, right? Starting from the requirement and we should continue it till the release. So absolutely correct answer is here option C. So when the requirement have been approved, when we get the requirement, we can immediately start the testing process. Very nice. Again, the question is how much testing is enough? How to decide that? So options, just focus on options, guys. This question is impossible to answer. This question is easy to answer. The answer depends on risk of your industry, contract and special requirement. And this answer depends on maturity of your developers. So how much testing is enough? That is nothing but same question related to exit criteria. When to stop testing? So absolutely correct answer is option C. Very nice. Let's try for next question. Now, again, in prioritizing what to test, the most important objective is what? Suppose you are doing some prioritizing, right? Prioritization of your work. So where you are going to focus first? So it's like I find as many fault as possible, test high risk areas first, obtain good test coverage, or test whatever easier to test first. So what is the objective whenever we do some prioritization? Okay. Mm-hmm. Let me correct you. I can see many of the people have written the option C, obtain good test coverage. That is our main objective whenever we are doing prioritization. But no, actual answer is option B. Whenever you are working for prioritization, you are just prioritizing your work. You should focus on the high risk areas of the application first. Okay? Good test coverage, you will able to obtain it whenever you complete that process. But which process to complete first? That is nothing but based on the high risk area of the software first. Means focus on the critical module first, and then you can continue the other module for a testing. Are you getting my point? So for this question, option C is a wrong. Correct answer is option B. Test high risk areas of the software application first. Are you getting my point? So in prioritizing what is important objective for testing, it is test high risk areas of the software first. Okay, try for this. Again, similar question but in different aspect. Okay, enough testing has been performed when time run out, the required level of confidence has achieved, no more fault found, the user won't find any serious fault. Think properly. What is the exit criteria? Again, related answer you need to provide. Think. Enough testing has been performed when time run out or required level of confidence has been achieved, and or there might be possibility no more fault found, or the user won't find any serious bug or serious fault, right? So correct answer is yes, absolutely option B. The required level of confidence has been achieved, definitely we can stop the testing. So it is make sure that all the requirement, everything, deadline, everything we have matched properly, then only we can take a decision to stop testing. So again, it depends on the risk of the industry, risk on that particular software application. But here in the given option, we don't have that risk option, right? But what we have, whenever required level of confidence has been achieved, we can stop the testing. So correct answer is B. So again, D is not a correct answer, right? Okay, great. Next question to all. Which of the following should not normally be an objective for a test? Think properly. What is not your objective? So to find fault in software, to assess whether software is ready to release, to demonstrate that software is doing, let me check the, yeah, software doesn't work, or to prove that software is correct. Which of the following is not normally objective for a test? A, B, C, D. What do you think? Which option is correct? Yes. So we are not here to prove that software is correct, right? Yes. In testing, you can identify defect, right? So to find fault in software application, that's again, okay, Nirmala, let me help you with this question. Question is asked, which of the following should not normally be an objective for test? So whenever you are doing testing, right, what is not your objective? So tell me, to find the faults in software, that is our objective. Yes, true, right? We are here to identify the defect. Okay. What is the second option? To assess software is ready for release. Basically, as a tester, once it is making sure that, right, that software is a quality one, that means it is ready to release. So that is our objective. Third, to demonstrate that software doesn't work. So yesterday we have seen na, objective of software testing. Demonstrate that software is doing what it is supposed to do, as well as we also focus. Software is doing what it is not supposed to do. So that is also our objective. We can do positive, we can do negative testing also. But last option is written for what? To prove software is correct. So we are in the testing field, not to prove that software is correct. We are here to identify defect from that software application. Are you getting my point? So first three options is your objective in testing. Last option, that's not your objective in software testing. Are you getting my point? So zero defect doesn't mean software is a quality one. So we are not here to prove that software is working or software is simple, correct. So we are not here to prove that. We are here to identify defect. Yeah, that's the reason correct option is because it is written not. Okay, rest of the things are objective, but last is not objective for software tester. Okay, so let's try next question. Okay, it's a fundamental day 2. Let's try this. The cost of fixing fault. Now think properly. Okay, as per the economic of software testing, if you remember that graph, if you have a number of defect, you have to fix it. But when we fix the defect, automatically cost will increase. Now the question is, the cost of fixing fault, what? You have to complete the sentence. Is not important, increases as we move product towards live use, decreases as we move product towards live use, is more expensive if found in requirement than functional design, and can never be determined. So what do you think? Which option is correct? Think properly. One more time, think on your answer. Okay. So cost of fixing defect. See, if you have number of defects in your application, definitely will be fixing it. But what will happen? Okay, Govind, I'm covering the topic again. See, if the defect is whatever defect you are finding out, right? That is related to SDLC cycle. So what is happening? If you found a defect at early stage, right? At the requirement stage, cost of fixing will be, see, this is what the cost graph, right? What is happening if requirement phase, if you found any defect, fixing cost will be less, right? But if you found a defect in design time, at the time of design phase, definitely little bit it will increase. Again, if you found at developers at that point of development, definitely cost will increase. Suppose late defect you find out. Okay, in testing phase, you find out some defect related to some other phase. Obviously, cost of fixing will always increase. So what is the question? Here the question is asked for the cost of fixing fault. Okay, so whenever we fix the fault, what will happen about the cost? So obviously we have seen now, if you start late testing, late defect you will notice and the fixing cost will always high. So the correct answer is it increase as move the product correct toward the live use. Okay, it will never decrease. Once you move to the live use means once you complete the development cycle and if you are finding out particular defect, the cost will be always high to fix it. So how come option D is a correct? Is more expensive if found in requirement than functional? No, right, Namrata? I think Nirmala, right? Yeah. So if you found it in requirement, the defect cost will be at this moment very less. It's a cheaper, right? We can easily fix it. So the option D is not a correct here. Govind, now it is clear? Yes. Now the correct answer is whenever we are
Uh,
increasing, yeah, we are moving towards the live the particular product, live use, automatically cost will increase. Okay, so that is the same concept. Like if you found late defect, cost of fixing defect will be always high. Okay. So again, rest of the options are incorrect. Correct answer is option B. Okay. What is COTS? Do you remember service model I have discussed? The COTS stand for what? Commercial of the shelf software, compliance of the software, change control of the software, or capable of shelf software? A very simple question. COTS is all about, the correct answer is it is a service model, right? If already implemented features are available in the market, then what we can do, somewhere if we have a requirement from the customer, we can ask a customer to take that or purchase those feature and we can customize too. So basically that is called commercial of the shelf software. Yes, the correct answer is option A. Very nice. Next question to all. Which of the following best source of expected outcome for user acceptance test script? Now consider what is user acceptance test. At the end, user will accept the delivery of the product. Correct? But here the question is asked for what? Which of the following is the best source for expected outcome in user acceptance test script? Means on based on what user will accept the delivery of a customer. or of your software application. Think properly. Based on what user will accept the delivery. So actual result, program specification, or user requirement, or system specification. What is the best source of expected outcome? Okay, write your answers quickly. So whenever at the beginning user will provide certain requirements to you, correct? And at the accepting that software application, based on what user will accept the particular software application, guys? Mhm. Obviously based on what? Requirements only. What is the best source? Correct. Option C is a correct, not option A. Okay. See, we have certain requirement first of all, right? User will simple provide you certain requirement first. So whenever, suppose here is our customer have given some set of requirement. Based on the requirement, we design, we develop, we test the software application as per the development cycle. And finally, it is time to release it now. Correct? So how come your user will take the or accept the delivery? Obviously, user will match the requirement, whether application it is developed as per these requirements or not. And that is called user acceptance testing, correct? The user will accept the delivery of the software application based on requirement only, based on not actual result. Are you getting my point? So here correct answer is user requirement is a best source. Based on this, user will accept the delivery of this software application. So correct answer is user requirements. Okay. Again, one more question. Failure is what? Found in the software, result of error, departure of software from specified behavior, incorrect step, process, data definition in a computer program, or human action that produce incorrect result. Again, think. Little bit confusing options, right? But still you need to think what is failure. Very nice. Okay, most of the answers are correct. Okay, let me help you. Okay, those are not writing correct option. Let me tell you first of all what is the correct answer here. Correct option is option B. Option B. Okay, let me explain how come. Here the question is asked for failure, right? When we talk about first option, found in the software and result of error. So guys, error always cause fault. So that's not a failure. Okay, so this is a definition for actually fault. Second, departure of software from specific or specified behavior. Departure of software means delivery of the software from specified behavior. So that is actually concept of failure. Okay. How come? Let me check another options too. See, incorrect step, process or data definition in computer program. Whenever computer programming is there, means it's all about the error. Any incorrect step in the code, that is your error. Any human action that produce incorrect result, this is also error. So in these options, even first option is for fault, remaining two simply defines error, then what is the correct answer? B. Deviation of a software application from its expected delivery, right? That is called what? Failure. So same sentence is written in this way, departure of software from specified behavior. That is called failure. The correct answer in this question is what? Option B. Okay. Try for next question. Fine. The purpose of requirement phase is, so still we haven't started with development cycle. Okay. But let me help you with this question. If you want to try, you can try the correct answer too. No issues. But still, what is this question? Let me explain. Yes. So consider like whenever we have a requirement from the BA, right? I mean, whenever the BA collect requirement from the customer, BA needs to validate those requirements. BA needs to analyze those requirements. And after that, BA will simple prepare certain documentation. So obviously, why we need a requirement phase? First point, to understand need of the customer. So here comes second option is also correct. To understand need of the customer. Okay. Now guys, to define scope of testing, that is also correct. Even we can use this requirement where you will get certain documentation, because we can freeze the requirement too. What is meant by to freeze the requirement? Basically, whenever any requirements are stable, okay, then based on those requirements, we can complete the full life cycle. So somewhere in sequential development, we can freeze the requirements too. That means there will be no change from the customer side. Requirement will be freeze, and even customer wants to update it. Again, as per the process, they can update those requirement document too. So somewhere we can freeze the requirement also. That's the reason. Correct answer is all of the above. Yes, D is the correct answer. Purpose of requirement phase is to freeze the requirement, to understand user need, define testing scope, because based on requirement only we test the software application. So correct option here is option D. All three options are correct here. Okay, fine. Try this one. Which of the statement below is the best assessment of how the test principle apply across test life cycle? So test principles only affect preparation for testing. Test principle only affect test execution activities. Test principle affect the early test activities such as review, or test principle affect activities throughout the test life cycle. What do you think? Which statement is the best assessment that how the test principle apply across the test life cycle? Yes, for this question, definitely correct answer is what? Option D. Yes. Throughout the life cycle, we can definitely get a help from test principle. So test principle affect activities throughout the life cycle. Let's see. Okay, next question to all. Again, see the question. What is the following statement, or which of the following statement best describe one of the 7 key principle of software testing? Guys, yesterday we have covered this topic. We have total 7 principles to follow. Let's list out one more time. So first is, suppose testing is context dependent. Every different application we can test differently. Second, early tests save time and money. Testing should start right from the requirement. Testing should continue till the release. Third principle, exhaustive testing is impossible. Checking each and every combination of input, some conditions, it is completely impossible. Defect clusters together, or defect clustering means what? Defect have a tendency to come in a group. So small number of module may help you to discover large number of defects. So that's the reason we have to focus on each and every module. Be aware of pesticide paradox. If you repeat same action, same test cases again and again, you will not found any new defect. So every time once you have a requirement, once it get update, you need to again start or review your test cases, update your test cases too. So be aware about pesticide paradox. Last two principle, testing shows always presence of defect, not absence of defect. And absence of error, it is just a fallacy. Okay, so zero defect doesn't mean software is a quality. Quality means if your software is developed as per the customer need, then we can call it as quality application. So try this. Which of the following statement best describe one of the 7 key principle? Automated tests are better than manual tests for avoiding exhaustive testing. Exhaustive testing is with sufficient effort and tool support feasible for all software, or it is normally impossible to test all input output combination for a software system, or the purpose of testing is to demonstrate the absence of defect. Think properly. What is the correct answer? Yeah, it's very simple. It's option number C. Yes. Normally, it is impossible to test all combinations of input and output, right? For a software application. So D is not a correct answer. Purpose of testing is demonstrate that absence of defect. Testing always shows presence of defect, not the absence of defect. So that's the reason out of 7 principle, C is simply defining third principle, that is exhaustive testing is impossible. Correct now? Okay. Let's see this one, which is not a testing principle. Again, think properly. Early testing save time and money. Defect clusters together. Be aware pesticide paradox, or exhaustive testing. Which is not a testing principle? Yes, it's again straightforward. Option Just now we have listed out total 7 principle. Here, what is the correct answer? Early test save time and money, defect clusters together, be aware of pesticide paradox, or exhaustive testing. Only small change you can see here, which will change the meaning of that statement, right? So, what is the correct answer? Which is not a testing principle? Absolutely. Correct answer is option D, right? Exhaustive testing. It should be exhaustive testing impossible, but that word is missing. So, exhaustive testing, that's not a principle, correct? This is not a testing principle. Rest three are testing principles only. We have seen now defect clusters together. Defect have a tendency to come in a cluster, come in a group, right? That is our principle. But exhaustive testing is not our principle. We have exhaustive testing impossible. That's our principle. Okay. Let's try next question. Okay, PDCA. Again, what is PDCA? Let me help you. Basically, when we start the development process, right? So before that, we need to make certain plan. I mean, the industry level, there is a planning. They simple follow one software process cycle, like how the software will simple develop. So first of all, they will do plan. Based on the plan, they will complete that process. Finally, we can validate the process and then we can take a necessary action. So PDCA stand for plan, do, check and act. So here A is the correct answer. Plan, do, check and act. This is stand for PDCA. Okay, so I will be covering it today once we start with our third module. Okay, so which is not a testing objective? Okay, which is not testing objective? Think finding defect, gaining confidence about level of quality and providing information, preventing defect, or debugging defect. Think properly. Which is not your objective? Sure. Yes. You know what? In software testing, we are here to identify defect from the software application. Correct now? Okay. So now tell me, I will first explain this question again and then you can decide what is your correct answer. So first of all, what we have learned, we have a different phases, right? Requirement gathering analysis, then we have design phase, then we have development phase. And as per the life cycle, we have here the testing phase. But what we have learned that if you start testing early in the life cycle, there are a lot of benefit. Okay, what benefits are there? See, if I start testing right from the requirement phase, first of all, I will able to identify defect early in the life cycle, correct? Then again, there is a one more advantage. Fixing cost will be less. Fixing cost will be definitely less here at this particular level. And there is a one more advantage too. If you find out any defect at the requirement phase, okay, related to that defect, you will be not able to identify any sub defect or let's say defect multiplication you are able to avoid. Means what? See, just now we have seen we have a principle. Defect have a tendency to come in a group. So defect always come in a group, guys. Means if you just miss one defect, there might be possibility maybe next phase you will get multiple similar kind of defect. So because of one, there is a possibility that you are getting number of defect in next module or next phase. So now tell me, if I help to remove this first defect only, automatically this defect will get removed. Correct? We have seen na defect clusters together because if you focus on 20%, 80% problem get automatically resolved. And what is this? Main objective in software testing is what? We are here to identify defect. We can identify defect, then we can prevent defect also. Prevention is also our main objective. We can gain a confidence about the quality. Yes, obviously, that is our main objective. So as per the ISTQB, there are many things they have defined. So yes, gaining confidence about the quality and all, that's our main objective. Prevention of the defect, that is our main objective. Identification of the defect, that is also our objective. So as a tester, you are responsible to identify the defect, but you are not responsible to fix the defect. So in this question, what question is asked about, which is not a testing objective. Finding defect is your objective. Gaining confidence about the level of quality, that is your objective. Even do prevention of the defect, that is also your objective. So how come? How you are able to prevent the defect? Start testing early. When you start testing early, automatically you are preventing your defects. Automatically we are trying to avoid defect multiplication. Because of one defect, there might be a chance you'll be getting number of defects in other module, and that you are able to avoid. That is called prevention. Take necessary action before that issue or problem occur. Correct? So prevention of defect is also our objective. Then what is not? We are not responsible to debug defect. What is debugging? Do you remember? I have discussed this point. Debugging is a process where developer can identify root cause of the problem and developer is responsible to fix the same. So debugging the defect, it is a responsibility of a developer, not a tester. So debugging defect, it is not your objective. So correct option for this question is what? Option D. Clear? Okay. Let's try this question now. Which of the following could be the reason of failure? Some options are given. I mean, some scenarios are given. Testing fault, software fault, design fault, environment fault, document fault. And these are the option A, B, C, D. Let's say 2 is valid and rest of all are invalid. So you have to check that which option is valid and which one is not valid. And based on that A, B, C, D, you need to answer. What could be the reason for a failure of a software application? Think properly, it's very easy. This is we have learned in defect, right? What are the reasons of defect in the software? So defect reason doesn't mean blaming to some person, blaming to some phase, right? It could be any issue. So here the same question is asked. Which of the following could be the reason of failure? Absolutely correct answer is very nice. Option D. All of the above are valid reason of a failure. Very nice. So that could be testing fault, that could be software fault, design, environment, or it could be documentation fault too. So because of that, you will be getting defects in the software application. So guys, here we have completed, the questions related to the fundamentals, whatever we have learned so far in software testing. Now the next module questions based on the development cycle and which I will be covering after development cycle module complete. Is this point clear? So let's continue with our third module now, software development life cycle, and what exactly we'll be learning here. Let's understand that. So first point, so far we have discussed only the basics. Okay. If you just want to remember the basics, just to prepare what testing it is, what defect it is, different testing principles you should know, right? Somewhere it is important to focus on the objective. What is the objective of developer, tester, and software testing? So in software testing, you need to focus on every requirement of the customer. You need to write a test cases for positive and negative, scenarios too. So everything you need to cover. Along with that, what is more important? The objective part. Why we should start testing early? Because we are here to prevent the defect. We are here to identify defect early in the life cycle, and we are going to ask a developer to fix it. So basically, early defects, if you find out, defect fixing cost will be very, very less. And for that reason, early testing saves time as well as money. Now it is time to start with this third module. Let me first introduce what exactly the learning objective it is and what you will understand in this particular life cycle. So first of all, we'll be starting with software development life cycle. Here you can see the software process development life cycle. It's all about the PDCA. So it is just a basic introduction, like what PDCA it is. I will cover this. I will explain you first what is process cycle, and then we will talk about development cycle. We are going to learn some development methodology. So guys, let us trained in IT, that's a agile. So it is more important to focus on agile methodology. Okay. But still, people might ask you question related to some older methodology. So very first, whenever IT starts, okay, at that time only one approach was there, that is a sequential, and there come waterfall model into picture. So waterfall was the first model, okay, which is available or which is still available in the market. Okay, so many applications, small applications, we can implement using waterfall. So it is time to understand what these different methodologies are and how come agile is so popular. What is exactly agile? What is the difference in agile and waterfall? All these points we are learning. So first of all, what is software process development cycle? What do you mean by process? See, in IT industries, three P's are very popular. First, it's all about what process it is. Second, whatever product you are going to implement. And third, different people, right? What are the different people we are using or the teams you are using to implement that particular application? So, what exactly process means? Process is all about whenever you want to develop any software application, how the process will goes on. So in every industry, the simple focus on software process life cycle. So software process life cycle, it's all about PDCA step. So PDCA, again, it is meaning of what? Very first, we will do certain plan. So industry defines certain plan, right? Based on the planning, you are going to implement that software, that is called do step. Based on the do, we can test it. So that is your check state. And finally, there is a act state. So what this PDCA life cycle says that whenever you start with any work, first make sure that your plan is ready with you. Based on the plan, you can implement the steps or implement that software application. Then you can check it and finally you can take a necessary action. So there is a possibility to develop any software application. Either we can follow one PDCA step or it might be 1 to n PDCA step. Means there might be a possibility again and again we are implementing or making change in the plan, or we are implementing the same application with some update possible. So there could be one cycle or there could be multiple cycle you are following to implement the live particular product, correct? So PDCA, it is all about software process development cycle. So guys, in software development life cycle, only the development cycle is not enough, right? We need to focus on which process you are following to develop that particular product. So that's the reason you should know very well what SDLC it is. You should know very well how many different approaches are there, right? And how exactly we develop, design, I mean, how the developer, tester, everybody, they will involve in the development cycle process. How they test, even how we test, how the developer develop the application, all it is also important to know. So in this PDCA step, what you need to understand it is, what is PDCA? So before developing any software application, organization has to check the process, what process they are following, right? And how the process will be. So process is very simple. Make some plan, do it, test it, and take some necessary action. If you feel that application is ready, let's deliver it. But if not, take again, you can follow the same process. That's the reason it could be one life cycle or one cycle to n cycle. Number of cycles also we can follow. But now it is time to understand about development cycle, our main life cycle. Correct? So how exactly it goes on? As I told you, first of all, if anyone asks you what is SDLC, it is a process through which we can design, develop and test high quality software application. But now the point is we need to understand each and every phase, okay, in a more relevant way. So what is requirement gathering and analysis phase, and how the BA is responsible for that, even how the different team members, technical teams get involved at that particular phase, we need to understand that. So let me start with very first requirement gathering phase. In SDLC, we have, this is a first phase, requirement gathering and analysis. Okay. In this phase, what will happen? Very first, user will provide certain user requirements. Okay. Based on user requirements, so requirements are the main point, correct? Based on the given requirement, BA is the first person who will collect the requirement from the customer and BA will analyze the same. And from that requirement, BA will separate out some business requirement. Okay. So as per the business need, BA will prepare some business requirements, and based on that, you will be getting BRS documentation, which is called business requirement specification. Same requirement get divided into in the form of technical requirement. Okay. So here, some requirements you are getting as a functional requirement. Functional requirement get prepared actually by the technical team. So let me just write here. It's a technical team. Technical team involves developer team. Okay. Technical, or you can say engineering team. Those are responsible to get or identify only functional requirement, and then based on that, here you will be getting FRS document, functional requirement specification. Similarly, from the given set of user requirement, system architect, okay, or I will say system analyst, not architect, system analyst. Those are responsible to get all the requirement related to software application. So software requirement get simply separate out. Now these software requirements, which actually include functional plus non-functional requirement both. Okay, non-functional requirement both. So based on functional and non-functional, they are responsible to prepare a document which is called system requirement specification document. So when it comes to the requirement gathering analysis, what the simple process we have seen so far, customer provides requirement, BA is the main entity who will collect the requirement, who will do analysis, right? But not only BA. At that phase, the other team member, like technical part will be understood only by the developer. So developer is also involved. They will understand the functional need for that software application, and they will prepare some FRS document. Similarly, BA will collect business need. BA will prepare PRS document. Similarly, system analyst will simple prepare software requirement in the form of functional plus non-functional. So all three documents, okay, which is in the same requirement gathering analysis phase. Again, in terms of agile, the latest methodology available in the market, BA is nothing but the product, we can say simple product owner. Remember, this is a BA, which is a one profile that we use in a normally in a what we can say the we have two different types of organizations, no? Product based organizations, and then we have what? A particular project based organizations. So somewhere in project based organization, we use a term BA. But similar term is called in product based organization as a product owner. The product owner is responsible to collect all the user requirements in the form of user story. So stories and requirement both are same. But these terms are used, terminology is different in different life cycle or different approaches. So previously we used to only requirement keyword, right? But now we are using same term in the form of user story. So you will be getting user story from the customer. Those user stories are valid or not, right? Or which user story is valid? Which user story you need to complete within a given time frame? That will be decision. That decision will be taken care by the product owner, nothing but your BA. So final responsibility of this complete phase to be controlled by the BA person. But other team member get also involved. So basically, whenever we start the life cycle, every team member doesn't need any business requirement. Not only they required functional, but they need complete software application detail. And that's the reason. In this phase, you will get multiple documents, but most common document that we follow, which is SRS. Why? Because SRS includes requirement related to software, again functional plus non-functional requirement both. So based on that document, you will continue your life cycle. So what the point you need to remember in this particular phase? In requirement gathering and analysis, BA is the main person who will collect the requirement. Analysis will be done. So whether any requirement is complex requirement, incomplete requirement, requirement is visible or not, right? Everything will be collected and simply analyzed by the BA. And then final document you will be getting, that is SRS document. You can even mention there are different documentation generate. like BRS document, FRS document, SRS document from the user requirement, right? But we simply follow SRS document to complete the process. So this is enough to understand about this particular requirement gathering and analysis phase. Now, once this phase is completed, so we have certain document with us, correct? And based on the document, next phase need to start their work. So what is the next phase? Whenever you have a software requirement with you, second phase, it is all about design, where some system architect, the team, those are responsible, those are system architect. Even, let me tell you, senior developers also involved. Okay, developer team, why it is involved, let me help you with that point first. Okay, so when it comes to the design phase, first of all, software application get designed in two different types. Okay, first is high level design and second is low level design. What do you mean by high level design? What do you mean by low level design? For every software application, first of all, it is decided that some overall architecture of the software. So high level design always describe overall architecture. So what do you mean by overall architecture of the software application? See, basically, what software it is, how many number of modules are there in the software, what is the relation, nothing but interface between that module. We need to focus on that part. Suppose for your software, any particular technology is required. Okay, what exactly technology you'll be using? Even which database you are going to follow. That high level information to implement the software, you will be getting under high level design. But then what happened? Functional design. Okay, whenever any software get designed, there are two parts, na? Front end and the back end side design. So design team are responsible to design the architecture. Okay, these are the number of module will be there. Then relation between the module. Let's say in your application, you have a register feature, you have a login feature, then there is a dependency. If user is registered, then only user can do login, right? So there is a dependency between the module and these detail, the overall detail you'll be getting under high level. But then developer is the main entity who will develop the application. So senior developer also involved in this phase and they are simply responsible to perform low level design. Low level design, it's more about technical part. Means if it is mentioned that here we are going to define number of module. Okay. The relationship between the module, how the which module or like example, which module is depend on which exactly module, right? Those detail, everything you'll be getting in the high level. But then internally, how to implement those modules? What could be the data relationship? What could be the class relationship between the module? Everything defined by the developer. So preparation of some algorithms, right? Flow charts, which is a technical part, right? How to implement that module? What is the internal structure? How the code should write for internal structure of any module? It is simply prepared by the developer. Okay, define some data flow in between that two module, how the data is actually flowing, right? So data flow, even you can simple define that class level architecture, it is prepared by the developer. Somewhere developer is responsible to prepare pseudocode. Okay, what is pseudocode? It's like combination of algorithm plus technical part, which is not executable at all. But still the pseudocode will help you to understand the entire application or that functionality, how exactly functionality will work, right? So pseudocode, which is not a executable code, but that is also prepared by the developer. Somewhere here you have defined in high level database is required. Okay, but actually how many rows or let's say how many columns? Rows can be dynamic, data entry can be dynamic, but how many columns you need? What type of data you are going to hold, the type of data, that is defined by who? At the time of internal design. That is nothing but low level design. So what you need to understand in this phase, design is a phase where design for a software application is actually implemented in two way: high level, low level. High level describe overall architecture, complete software, different module, their relationship, database, technology used, defined in the high level. But how to implement that module? Logics will be implemented in a low level design. So internal things before writing actual code, whatever it is required, flowchart, some pseudo code, algorithm, that is defined by the senior developer. Correct? Even UI design of the software application also done by whom? The developer guys. Okay? How the software will look in one form, how many fields should be there, how the field should be placed, what the logic should be written over there. It is responsibility of a developer. So design phase where architect team plus developer team both are involved and they simply make certain design. Architecture of a software application they implement. Clear? And once the design phase is ready, the whole information about high level, low level, they need to describe in certain document. So in SDLC, the best part is what? From every phase, you will get certain document. From design phase, you will be getting DDL document, or you can just call it as DDS document. Detailed design specification or detailed design document. So basically, these documents will help you to understand more and more about that field. Even not only this much, you will be getting some use case diagrams in the design field. Okay. Design phase is all about architecture of a complete software. So how user can interact with the software, that is you will be getting in the form of some class diagram, some kind of use case diagram, where you will understand flow and the relationship between user and that application. So let me explain you what is a use case. Okay. So suppose let's take a very simple scenario of ATM machine. Okay. So I want to simple withdraw some amount from the ATM. So how the use case will design by the design team? In use case, the actions which is represented or actions which simply define relationship between the software and user, that is always represented in the form of ellipse. The directions, arrows, will simple point out the relation. Again, the action which is moving to user to software or software to user, that you will be getting with the help of arrows. Again, this is the image for actor. Actor means how many participants or how many users of that software application are, right? That is represented by this stick diagram, which is called actor. So for ATM machine, what is the best or what is a simple scenario or how the diagram is simply prepared? See, we have a backend software application available for ATM, and here we have a actor. So can I say that currently for ATM machine, we needed two actor. First, actor one, which is the user. This is your end user, right? It could be anyone, technical, non-technical person. And second actor is actual software, correct? Software application, which is actually at the backend side, which we can't see. What user can do? So user can first visit to ATM machine. User can do the first step, insert card, right? Insert card. That's my first use case. So card will be accepted by the system. System will do at the backend side validation part, right? And that is also we are not able to see. If your card is valid, you can again get the access of your screen, that what the exactly step you want to do, right? Which step you are going to follow. Let's say if you want to follow withdraw or you want to check your pin number, whatever it is, right? So many options mostly you'll be getting. Suppose if I just simple write, okay, I just want to do withdraw option. In that case, you will put your email ID, sorry, not email ID, PIN number, right? Then you can write your amount. Even you can check your account, right? Saving account, current account. Finally, these details will get by that particular software application. It will be validated by that software at the backend. Whatever amount you will write, is it really available in your account? Then only you will able to see, I mean, you will get that amount in cash, correct? So what this diagram explain? Relationship between software and the user. And you know, in technical word, this is called use case diagram. Okay, why I'm explaining this, you know, because we have one technique in black box testing, use case based testing technique. So where you need to understand the design, which is prepared by the design team, even based on the use case. diagram, you will be getting in SRS use case templates also, which will help you to understand relationship between user and the particular software. And based on that also we can prepare a test cases. So use case based testing means for every use case you can write your test cases. Are you getting my point? So how the card is validating, okay, how the user is inserting card, how the software gets simple validate that card, even how we can simple go for the withdraw deposit, which action you want to do, right? Then even pin number validation, everything we are able to test. And for that reason, this kind of diagram also need to be understand. So guys, where you will see the diagram, it is in the design document. Similarly, you will be getting use case templates from your requirement document too. So based on that information, we can start writing our test cases. So for test case writing, you don't need to wait till the application get ready from the developer side. Try to understand. We can start test case writing from the requirement, and that's the reason all these documentations are important to know. So here I have just given a simple example for use case diagram. So for now, just understand for every application, what is the use case? It is just how the user will interact with the software application that is represented in this kind of diagram. Okay, where you will able to see the actions represented with ellipse, the arrows, which simply state that action is from user to software, software to user, and then you can see the actor. How many users that access or they can access the software application. For ATM, only one-to-one communication, correct? So that's the reason actor 1 is enough. Point is clear? So this is all about a design phase. Means in requirement phase, what we have seen, from the BA, requirement get validated, requirement get analyzed, and you will be getting different documents like BRS, FRS, or SRS document. So most common document that we follow, that is a SRS one. After requirement gathering phase, we have a design phase. In design phase, again, you'll be getting design documentation. So some kind of architectural plan, high level document, low level document, right? Technical document, you will be getting in design. Most common, detailed design document or detailed design specification, you will be getting, which include everything. Okay, all the technical part, architectural plan, everything you'll be getting in the design. Once two phases completed, then we have a third phase, which is development. What is actually happening in development phase, guys? Who are responsible? You are already aware. Developer is responsible to develop the software application using certain programming language, whatever technology is decided in the design phase. Based on that, they develop the software application. So not only development, okay, development of code. Developer is not responsible of development of code, but developer is responsible to do unit testing. As I told you, whenever software includes multiple module, correct? So how the developers start writing their logic? They don't write every module at once, okay? Generally, every module they prepare separately, every module they test separately. So whenever software application or a smallest part of application is getting tested by developers separately or in isolation, that is called unit testing. So unit testing is always responsibility of only and only of a developer. Okay, make sure that this is a first level. Whenever code is ready, it will be reviewed by tester, it will be reviewed by developer too. But actual testing, unit testing, it is always done by the developer. Okay, developer is not only responsible for unit testing, developer can debug the code. So debugging is also responsibility of a developer. What is debugging? Identify the root cause of the problem and fixing it. That is called debugging. So defect fixing also done by the developer. Who will fix the defect? Developer is responsible to fix the defect. So these are the different responsibilities of a developer. And once the developer develops that particular code, you will be getting some code related documents also. So whatever code related documents are there, from that coding phase, from that development phase, you will be getting those documentation too. This is our third phase. Okay. After development, as per the SDLC, we are having fourth phase, that is software testing. Now, guys, this is the main phase that we are going to learn in a deep, right? So many topics, so many concepts will be learning in testing phase. But what exactly testing it is, we have seen that software testing, it is a process where we can test the software application to identify defect, correct? So in software testing, you will be learning different types, okay? Different methods. There are 4 levels available in software testing. So these we are learning. Example in types, there are only 2 types available in software testing that you need to remember. For now, I'm describing in a very, very short, okay? But in future sessions, we are covering this topic again in a deep, right? So definitely, what are the types of testing? If you search this question on Google, you will find out there are 50, 100, 150, 300 types of testing, and which is true, okay? But what is the correct answer? As per the ISTQB, there are only 2 types. First is static testing. Second is dynamic testing. In a technical word, you can just call it as verification and validation. That's it. How many methods are there? Only 2 methods. We have black box testing. We have white box testing. That's it. How many level? 4 level. So application get implemented in this 4 level. First is unit testing. After unit, there is integration. After integration, there is a system testing. And finally, user acceptance testing. So basically, how the process will goes on. Guys, in software testing, very first, whatever requirements are there, till the development cycle. Means see, we have requirement phase, we have design phase, then we have a coding phase, right? So after code only your software will be ready, right? Again, how the software will be ready? It's like a complete software? No. Very first what happened? At this time code, whenever code get designed, developed by the developer, so initially you'll be getting only one single module. Okay. So module by module software will be implemented by the developer. So let me explain. Very first, you will be getting module wise. Then these module when we combine, then based on that, we can simple follow integration. So integration means what? See example. First requirement will done, design will done, then coding. But till this particular requirement to code, what is the responsibility of a tester? Is that mean tester is going to be wait till the application get ready and then we can test it? No. As a tester, your responsibility is what? Prepare your test cases. So for test case writing, you don't need software to be ready. Okay. From which point we can start? So obviously once you have a SRS document with you, once your test plan is ready with you, you are aware that what to test and how to test. Definitely we can start test cases from this phase only. So based on requirement, we can start writing test cases. That is a fact. Second point, how the developer develop the code and how we test it. At this moment, developers start with first unit level. Suppose this is a register module. This is a login module code. Developer test each and every functionality independently. Then this level actually called unit testing. Okay. So developer is responsible for unit testing. But then what happened? Developer need to merge the code. So where the register module got integrated with login, this level, it is actually called integration. So what integration means? Combine multiple module together and test their relation. So modules are independently working fine. But when we combine in a complete software application one by one those module, is it really those module are working fine? That is also we need to test. So that level is called integration testing. Integration testing, it is a process where developer combine the particular module and as a tester we can test relationship between the module. So at this level, who are the participant? developer plus QA team. Both are responsible to do integration testing. Because see, code merge, that's not your responsibility. That is done by the developer. But after merging the two module, three module code, we have to test the relation between the module. Are you getting my point? So first level is unit testing, second level is integration. Suppose in your software application, you have 3 to 4 modules available. Once all 4 modules get integrated, what you will get? See, I'm having 3 to 4 modules in my software application. Login, search, log out, right? Whenever all modules get integrated, finally you will be able to see your complete software. That's the reason after integration, we will get complete software for a testing. And you know that is called what? Third level, where we can conduct system testing. And let me tell you, system testing, it is only responsibility of a QA. Here developer is not involved. So as a tester, you can test functionality plus non-functionality for your system. And that is your third level. Whenever you feel that, yes, software is ready for delivery, then at the last, we are having where software is simply released to the customer. So at this release level, where the user acceptance testing will happen. It is done by the customer, it is done by the end user. Because there are two types, alpha plus beta, that we are learning again. Okay. So alpha testing, which is actually done by that real customer. Customer will check that, okay, whatever requirement he have provided based on that application is ready or not. Then that process of testing is called alpha testing. But somewhere what we are going to do is application develop based on a customer need. But who is using it? End user. So we are currently suppose end user. We can use a different software application, right? So it is important to test that application from the real user too. Those are actually going to use that software application. So whenever any application test and the in the live environment, or let's say at the user platform, that is called beta testing. So alpha plus beta both are type of user acceptance testing. If every application is implemented as per the user, then only user will accept it. Simple. So there are 4 levels in software testing. Okay. No software get implemented. It's like a direct software. Okay. It's not like that every application get implemented directly. Slowly, the process-wise process, step-wise step, you'll be able to see your application. So there are 4 levels, every level having a separate objective. Try to understand. And that's the level. That's the reason. Software testing, it is simply carried out in different levels because every level having their unique objective. Unit testing is first, integration, then software, and then you'll be having what? User acceptance testing. Even one more point. Whenever in the interview you are discussing about the levels, don't change the sequence. Sequence remains same. You need integration system UAT. And this is how we test the application. Again, guys, we don't test only till this. Like after releasing, is there again we need to go for testing purpose? Yes. Generally, there are different types we'll be learning. Like somewhere you will be understanding what is build validation test, or which is also called as build verification test. Okay. Some special type. So we'll be having, let me write again, build verification test. Okay, many people are aware about this, where you will be learning for smoke testing and sanity. So we'll be learning about smoke and sanity. The common, very important topic, change-based testing. Whenever there are changes, so mostly first a change, like whenever every time defect will fix by the developer, we always go for retesting. As per the ISTQB, it is called confirmation testing. It is confirmation testing. And again, whenever there is a change related to the software, like somewhere any new feature got added, any feature got updated, deleted, then for every change, we always go for regression testing. And regression testing is most important in automation too. So we have some special type to be covered. What are build verification? What are change based testing type? Even what are experience based testing type? Okay, everything will be learning. But in experience based, two types again important: exploratory and error guessing. So this is how you will be learning the complete testing phase. Correct? But try to understand requirements are the key point. Main objective is to prevent, identify, and ask a developer or get them fixed from the developer team, right? Those defects. That is our main objective. Then we follow certain types of testing, methods of testing, even levels of testing to complete this full process. And this is how the testing phase goes on. Okay, when you test the application, when you make sure that application is now quality, what is the next phase then? After testing, we have a fifth phase, that is deployment. You know what? In deployment phase, basically it is your production environment. In production environment, we actually test whether software is properly installing at a customer platform. Remember, so on a customer machine, on a customer platform, is your software is working properly? That we test. Okay. Again, here we don't release only software. Along with the software, whatever documentation you generate, right? Somewhere it is called report, somewhere it is called help document. That also we can release to the customer. So deployment, it is nothing but delivery of your software application to the customer. Correct? But here we need to first do final testing. Check that, make sure that your application is working on a customer platform. If everything is okay, we can release documents, we can release software application, we will hand over everything related to the software to our customer. And that is actually called deployment phase. Once application will deploy, then you are in the maintenance phase. Now see the one more interesting phase, which is called maintenance. What is maintenance? It's like a customer support. So whenever you release a software application, there might be problem with the software, there might be some concerns about software that customer wants to simple update you. Customer can communicate with you based on the requirement of the customer. Again, we have to provide a maintenance to that particular customer. But how the process will goes on, let's see. Suppose here we are. Okay, as a IT person, we are responsible to provide a maintenance to our customer. Okay, we have this customer here. Fine. Very first, in maintenance, there are four types. We are here to first provide preventive maintenance to our customer. Preventive means whenever you are releasing a software application, making sure that application is a quality. So basically, there should not be issue that should not be focused by the customer. Correct? So very first, we are providing any preventive maintenance to the customer. But after release, might be possibility. If customer found any defect, let's say any failure in a software, customer can report that. Okay, so if suppose customer found any failure, then customer will report that failure. So suppose customer is reporting you, report a failure, what you guys need to do? What type of maintenance you are providing to the customer? If still customer notice any failure, you need to correct that. And for that reason, second type is corrective maintenance. We can simple provide corrective maintenance to our customer and we will correct that particular problem. Okay, we means again full team is involved, developer, tester, everybody get involved. Whatever customer provides to you, based on that we need to provide a support. So there is a second maintenance type, corrective. Suppose tomorrow your customer wants to upgrade your software. Let's say customer wants to add some new feature in a software application. Guys, which maintenance you will do that? Or we will provide to the customer? Then here we have a perfective. Okay, perfective. Let me write perfective maintenance. So as per the need of the customer, whatever new feature customer wants to add, we need to provide a maintenance to our customer. So we are providing perfective maintenance. Finally, there might be a change. Customer wants to update a software in terms of enhancement or in terms of like from older platform to new platform, customer wants to completely make some changes in the software. So somewhere we can call it as re-engineering. Okay, now currently customer have asked you to write or implement the software which is a web application. Now customer wants same application which should use on mobile device too. So it is completely changing the platform. There also we can provide a customer adaptive maintenance. So adopt those new feature and provide that features to the customer. So basically, maintenance is like a customer support. Whenever customer provides you or asks you some kind of changes, we need to provide a support to them. And there are four different types of maintenance: preventive, corrective, perfective, and adaptive. I hope the point is clear. And this is your complete life cycle. The software development life cycle, it is used to implement a quality software application, design and test quality software application, but it includes multiple phases: requirement gathering analysis, design, third is development, testing, deployment, and the last one is maintenance. So whatever I have covered, it is mentioned here. Just observe. So first of all, the process, project and product. What is the difference? Process is like the technique through which you develop the software application. So it is specified method of developing software. Project is other hand software application which fulfills single client need, that is called project. And we have discussed about product too. Whenever application get developed based on the market need, that is called product. So here what is software development life cycle? First statement, it is a process which is used by software industry to design, develop and test high quality software. In SDLC, main aim to produce high quality software which meet and exceed customer expectation, reaches completion within time and given cost estimation. So we have to focus on the quality parameters too. SDLC includes detailed plan describing how to develop, maintain, replace, alter, or enhance specific software. So planning is important in every phase. But the process start with this particular phases. It include different phases like first is requirement gathering analysis, design, development, testing, deployment, and last one is maintenance. And here, if you notice, I have described in short each and every phase, different documentation, and the responsibility of a user. So basically, requirement gathering. Here, the BA is the main person who will collect the requirement from the customer. And in agile term, we can call it as product owner who will collect the requirement from the customer, and those requirement get validated. So feasibility study of requirement, requirement elicitation analysis. So which one is valid, which one is invalid? That analysis done by the BA. Requirement validation. Other requirements are simple, a concrete requirement, complete requirement. It should not be missing, right? So every point get validated by the BA. Certain documentation you will get like BRS, FRD. So this is related to D stand for document. So BRD, FSD, that is functional requirement document, or baseline SRS document. So based on these document, who are the user? Business analyst and some subject matter expert like system analyst. Then you'll be having some technical team. Those are responsible in this field, and they prepare different document. But the main document that we follow, that's SRS. Because to start with the process, we don't need a business need or some other contract related document. We need a document related to software. For that reason, SRS is a main document which is considered. Design phase, which is actually done by the system architect. So high level, low level design, these are the two types. How to explain? High level describe overall architecture. Low level describe detailed architecture about the software. Simple. So document architectural plan, database design, screen design, UI or module design, some program specification, algorithm, flowchart, everything get included in the design phase. And these are the participants. Technical user, UI designer, senior developer get involved. Then we have seen development phase, which is responsibility of a developer. But see how the developer simple perform their activities. So developing code, interlinking between the module, merging it, right? Code merge, unit level testing, debugging. These are responsibility done by the developer. And documents are working code, some unit level report, some module interlinking report you will be getting. And yes, developer, then leader, project manager, technical team leader, these people get involved in this complete development phase. But yes, more relevantly, development is done by the developer. Then we have a testing. Okay, in testing, check the implemented functionality with respect to customer requirement. So most common thing, based on the requirement, you'll be performing software testing, tracking the defect till the closure. Identify it, ask a developer to fix, but till defect get closed, track the full process. Okay. Again, there are a lot of types to be covered. So main document that you prepare while doing testing, those are nothing but scenario document, test case document, script, defect reports. These things will be preparing. And the user, obviously tester is the main user, but other participants also involved, right? So BA, test manager, project manager, all these things, like these people are generally involved. But most relevantly, testing phase is done by whom? Software tester. Yesterday we have seen that, right? Testing can perform by everybody who is responsible in that team, but it is mostly done by whom? Software tester. Last two phases, deployment. In deployment, installation of code, making program or other component available for customer use, creation of manual, user manual, and sometimes we can provide a training to the user also. Suppose some technology is new and customer is not aware about that, so we can provide a training to them how to use that software. And yes, release notes and user manual, that are the documents. Deployment, every team member is involved. Again, manager, technical lead, leader, tester, developer, everybody get involved. Last is maintenance phase. There are four types: preventive, corrective, adaptive, perfective. Document any change requests, code related changes, or technical documents you will get. And again, the all team members get involved because it is a like a customer support. And here, this entire process is called software development life cycle. So tomorrow we will continue again with the next topic, like how many different approaches are there and how many different ways are available, right? Where we can simple follow the different methodology. So please go through the documents again. And if you have any query related to the topic, again, we will have a discussion on this tomorrow. Okay. I hope it is clear, but still go for it one more time from at your end. And if you have any query to ask me, we will discuss it tomorrow. Okay, so
Yes,
I
ma'am.
think let's stop the session. Bye, everyone. Take care. Bye bye. Thank
Bye,
you.
ma'am. Thank you.
Have a nice day.